Hello, ladies and gentlemen. Today we'll be learning the last piece of the mole puzzle, volume conversions, and going to the mole, and then other things. So after today, you should be able to calculate the volume of a gas at standard temperature pressure, given the number of moles, and back and forth, and then also be able to perform two-step volume conversions, example being like atoms to liters or molecules to liters. Now, this is the new information. For 1 mole of any gas at standard temperature and pressure, the volume occupied will be 22.4 liters. So no matter what gas we're talking about, if it's at standard temperature and pressure, it will occupy the same amount of volume. So that gives us our conversion factor of 1 mole of any gas is equal to 22.4 liters of gas. And we're going to talk about standard temperature and pressure, which means at 0 degrees Celsius, that's the temperature, and then at 1 atmosphere of pressure. I do want to show you this inequality can now be written as 1 mole over 22.4 liters, or 22.4 liters over 1 mole. And for our one-step problems, those are the two that we're going to choose from. So here's an example of a one-step problem. How many moles of helium gas will occupy a volume of 149.3 liters at standard temperature and pressure? So first we're going to talk about our known. Our known is the number we're given, 149.3 liters. And we're talking about of helium. Our unknown, how many moles? It is important that you make sure as you're doing these problems, you're still writing all of your units down, because in our next chapter, in our final chapter, we're going to be going from units of one thing to units of another thing. So just want to make sure we are writing units. So for our plan, it's going to be one step. We're going to go from liters to moles. Start with my known over 149.3 liters of helium over 1. Now for all gases, our inequality, our fraction, our conversion factor does not change. It is always either 22.4 liters over 1 mole or 1 mole over 22.4 liters. Because we start with liters here, I know liters of helium has to be on bottom. And I know that number is going to be 22.4. And on top, I have 1 mole of helium. That is my unknown. So I'm just going to do the math now. The units are going to cancel out. And then when I actually do the calculations, I have 149.3 divided by 22.4, and that gives me 6.67 moles of helium. So that is a one-step problem. Now, if you start with moles, this is going to be flipped over. Okay. And we're also going to do two-step using the volume as well. So how to convert moles into particles and vice versa, we already know this. that 1 mole is equal to 6.02 times 10 to the 23rd atoms, molecules, or formula units. And yes, that unit does change depending on what we're talking about. Our second thing that we always know is that 1 mole is equal to the atomic mass in grams, or the molar mass. And then our third conversion factor is that 1 mole of any gas is equal to 22.4 liters of any gas. Okay, so we're at the point where you know all three of these conversions. So we're just going to write them on our diagram. And the mole is kind of the go-between, as I've said before, between any of these three things. So you can go from particles to moles, then from moles to volume, or you can go from moles to mass, mass to moles to volume. Any of these three things, the mole is the interchange of all of them. So we're going to write on your notes each of the inequalities going from one thing to another. So let's start with representative particles. If I go from a number of particles to my mole, I'm going to have 1 mole over Avogadro's number, 6.02 times 10 to the 23rd. If I go the opposite way, from moles to particles, I flip this inequality. So I have 6.02 times 10 to the 23rd over 1 mole. Okay. In our next one, we have mass. If I go from mole to mass, I'm going to have my molar mass on top divided by 1 mole. Now notice sometimes I write mole with an E and sometimes I don't. You can abbreviate it, just MOL. It's not going to make a difference. Just as long as you know if we're talking about moles or molecules. And then to go from mass to moles, we're going to have 1 mole over the molar mass. And next, we're going to do volume of gas to moles. So if I'm going from a volume of mass to moles, I have 1 mole on top, and then the unit we just used, 22.4 liters. If I am going from moles to volume of gas, I am going to have 22.4 liters on top of my 1 mole. Now, that roadmap right there is very important. So make sure you understand and know all of those conversion factors and how to get from one place to another. Okay. So we're going to do one question, and I'm going to kind of show you how to go through the roadmap from where we're going and what we're going to. So our first thing is looking at our problem and figuring out our known and our unknown. What volume would 4.32 times 10 to the 23rd atoms of krypton gas occupy at STP? So my known is going to be 4.32 times 10 to the 23rd. And my unit is atoms of krypton. My unknown, it says what volume. So I know it's going to be question mark liters of krypton. So now, how do I get from one to the other? If I look back at my roadmap, it will tell me. So I'm going to go back here. I'm going from atoms, particles, to volume. So I know I'm going to need to go from particles to moles to volume. So if I go from particles to moles, I know it's going to be 1 mole over 6.02 times 10 to the 23rd. Then I'm going to go from moles to volume. So I know it is 22.4 liters over 1 mole. Okay. So those are the two fractions or conversion factors that I'm going to use. Let's go ahead and write out our plan just like we went through on our last paper. So I know I'm going to go from atoms to moles to volume or liters. Okay, so to get from atoms to moles, I know I'm going to have to use 1 over that 6.02 times 10 to the 23rd. To get from moles to liters, I know I'm going to have to use the 22.4 liters over 1 mole. So let's start with our known. 4.32 times 10 to the 23rd atoms of krypton over 1. Then I already mapped it out. I have 1 mole of krypton over Avogadro's number. That's atoms of krypton. And in my last step, I know I need to go from moles to liters. So I need to use 22.4 liters is equal to 1 mole. So I have 22.4 liters of krypton over 1 mole of krypton. When we do these, our units cancel out. So atoms of krypton and atoms of krypton, mole of krypton and mole of krypton. So I know my answer is going to be in liters of krypton. Now I need to put this in my calculator. Be very careful when you're putting this in your calculator because a lot of calculators need parentheses around this second thing, around the second number, because when you're dividing, you want to divide by that whole thing, and that's what the parentheses tell it. So in my calculator right now, I'm going to go ahead and put 4.32 times 10 to the 23rd divided by, put in my parentheses, 6.02 times 10 to the 23rd, and then multiply by 22.4. When you do all that, you should get an answer of 16.0744186. I only went 2 decimal places, so it's 16.07 liters of krypton. If you guys have any questions, please let me know. Definitely use the roadmap that we just filled out to go from one to another. Have a wonderful day. If you need me, let me know. I'm here to help. Have a good day.